Hi everyone, my name is Eric Ananga. I'm a student of the University of Ghana and in the computer science department. I worked on a project, and the purpose of this video is to showcase my project. I want us to look at what the system is about. That's the system overview. So this is a project, a smart traffic and a street light control system built on Arduino. First of all, it reads a light dependent resistor to automatically turn the street light on at night and off during the day. Secondly, it will monitor any emergency flag, and if it is triggered, all the LEDs and the buzzer sounds will immediately override anything else. And for the third one, it runs a traffic light state machine cycling through the yellow, the green and the red. So when it is green, if a vehicle is detected, the green phase will extend by 5 seconds to reduce the unnecessary stopping. So all the timing uses the millisecond for fully non-blocking. So this will result in another. I'm starting the simulation. I want us to look closely at the color change in light. You can see the green here. It will switch to the yellow, and after some time it switches to the red every 5 seconds. This is the buzzer connected, the motor, and no other equipment here, the resistor, and this is just a setup. But what we are focusing on is the LED, the red, the green and the yellow. Their color change after every 5 seconds. Hello, so guys, we are supposed to press the vehicle button during the green to show the extended duration. So let's wait for the green. Yes, it's on the green now, so we are going to press the button here. Let's observe carefully. So you all can see that when we pressed the button, it delayed longer than usual before moving to the yellow. Yes guys, since we are using the Arduino online, we want to cover the the light sensor to see what happens. So over here we have our photo sensor. If I should lower it to the minimum as a photo resistor, you would see that the light here, which is the street light, is on. If I should increase it, let's say up to 50 is okay, or 52, you would see that the street light will go off, which tells you that when we expose it to illumination, it goes off. Then when we expose it to less intensity of the illumination, the street light comes on, just like there. Welcome back guys. So the next step is to press the emergency button to show all the red buzzer, the red light and then the buzzer. So we'll also release it and show recovery. Then we'll show the 4-state triggering buzzer. So let's go. We are pressing the emergency button over here. We are not releasing it, so you can see that it keeps overriding red activated throughout. Then when we release, we realize that we have the buzzer activated, just like you can see on the screen. Watch closely. Yes, the buzzer is activated. Yes, so that is all for this session. Hello guys, we want to combine all that we have done so far, starting from the street light to the vehicle detection and finally the emergency. So we are running the simulation here. So we want to work on the street light first, where we would use our photoresistor, which is here, to test the illumination. Let's take it to the maximum. At maximum, realize the street light is off, but at the minimum, the street light is on. Then we'll work on the vehicle detection over here. When I press it, you would see that the green light will take a long time before switching to the yellow. When I keep pressing it, it doesn't move from the green, it stays there. That is showing that an interrupt has been triggered. Yes, then finally we would hit the emergency button. When we hit it, you realize the buzzer has been activated. The buzzer, if we press it and we don't release it, the red lights keep overriding. This and this, they keep over. Hello guys, finally we are bringing our project to an end. We want to briefly go through the code, explain the state machine, the millis timing, and the LDR. So this is our code over here. So this system uses 4 states. That's the red, the green, the yellow, and the emergency state. The variable, which is the current state, will track the state which one is active and switch to the traffic cycle. It decides at what state should I go to the next one. Then the millis timing, instead of using the delay, which will freeze the whole program, the code will use millis to track the elapsed time. The state starts millis, it records the timestamps, and also this keeps track of the system, and so that it makes it responsive at all times. Then the threshold of the LDR, it reads an analog voltage which is converted to resistance, then to a value that has a photoresistor formula. So when it is set to 50, like 52, the one that we looked at, we realize that the ambient light, it drops below, so that's night time. Then the street light will turn very high, that is being on. So realize that is why in the daytime we have the street lights off, ones that uses solar. Then during the night they are on. So I'm sorry, this is just like the vehicle detection. This is just the code, the whole code, just like the street light over here, the high and then the low. Sorry for not going through with you, but I think this should do. Yeah, it is just the code and nothing much. So guys, we want to demonstrate the gate opening on the green and closing on the red. So back in our code, we wrote the code. The instruction was for the gate servo motor to open at 90 degrees when it opens on the green, and then on the red at 0 degree. So we are going to run the simulation and observe it. So on the red, we can see over here that it's at 0 degrees. Then it moves to the green, which is at an angle of 90 degrees, which is demonstrating that the gate opens on the green and closes on the red. Other than that, it opens at 45 degrees for the yellow, and that is it.